All right, learning target 2 video, evaluate relationships in function notation through substitution and by graph. Function notation is something that is new to us, at least, but not necessarily like a new concept. It's just a new way of writing something. So function notation, typically what you'll see for this is like f of x, g of x, h of x. And just like what I just did, it's pronounced, that's how you write it. And the way that you say it is like f of x or g of x. And what this means is that x is a function I said that backwards. That f is a function of x, and that's where the f of x comes from. That f is a function of x. In terms of like input-output, this means that x is the input, and the output is f of x. So we'll draw this kind of little function machine thing again. And this machine is f of x. This function is f of x. It takes x going in, and it spits out some value f of x. So x is your input, f of x is your output. You can think of it as basically f of x is kind of the same as y, whereas before we had like input of x, output of y, and so a lot of times we made these like xy tables. It's kind of the same thing, except for now we replace y with f of x, and it's just a way of writing something and of saying it. So it seems really confusing. This doesn't mean f times x. It just means that f is a function of x. So you put in an x and you get out some f of x value after it did some sort of rule to it. It'll make more sense when you see examples. So this example, y equals 2x plus 4. This is something that is very familiar to you. That's just a very simple linear equation. It multiplies x by 2 and then adds 4 to it. In function notation, this now changes to f of x equals 2x plus 4. So again, all you're really doing is replacing y with f of x. Then in this next part, the way you read this is f of 3 instead of f of x. So all you've done is replace x with 3. So f of 3 equals 2, and then you replace x with 3 plus 4. So it's just the only difference between this line here and this line here is that you've replaced x with 3 right here and right here. And so then it's kind of the same as what you did before. You just calculate what this equals. 2 times 3 is 6 plus 4 is 10. So f of 3 equals 10. Or in words that you're a little bit more familiar with, if I input 3 for x right here, then I get 10 as an output. Okay? Input of 3, output of 10. So f of 3 equals 10. Couple more examples for you. Here's f of x, negative 2x plus 6. Here's g of x, x minus 1 squared plus 9. and so we are evaluating the expressions for the given values. This is f of 8, and what that means is I'm taking x and replacing it with 8, so I have f of 8 equals negative 2 times 8 plus 6. So that's f of 8 equals, this is negative 16 plus 6 is negative 10. And so my final answer, f of 8 equals negative 10. I'm going to skip over to here and leave this middle one alone for a second because it's a little different. This is g of 3. And what g of 3 means is I take x and I replace it with 3. So now I have g of 3 equals 3 minus 1 squared plus 9. So 3 minus 1 is 2, squared is 4, copy down the plus 9, so g of 3 equals 13. And again, that's my final answer. So I take a 3, I plug it in for x, and g of 3 equals 13. Okay, this one is backwards. This is asking me to find x when f of x equals negative 18. So since these two things are equal, I can replace f of x with negative 18 in this equation. So instead of having f of x equals negative 2x plus 6, I'm going to have this replaced with negative 18. So this is now negative 18 equals negative 2x plus 6. And now it's just solving for x like you did in Unit 1. And I get x equals positive 12 when f of x equals negative 18. So I was taking a negative 18, replacing f of x with negative 18 in this equation right here, and solving for x, and that's where I got 12, so x equals 12 when f of x equals negative 18. You can also do this from a graph, and a lot of people think this is even easier from a graph. If you understand what this notation is saying or asking you to do, it is very easy. F of 4, again, our little hint here is this is basically where x equals 4. We've replaced x with 4. So I look where x is 4, that's right here, and I look up, and f of x is this line, and f of x right here is 1 at this point, so f of 4 equals 1. All right. F of 2, this is when x equals 2, so I look here at x equals 2, and I follow it up, and I find that this on the y-axis is 4, so f of 2 equals 4. I want to know x when f of x equals 2, so I'm looking for where does this line equal 2 on the vertical axis, and it looks like it equals 2 right there, and right there, and right there. So I'm looking across this 2 line, 2 on the vertical axis, and x is about 3.2 and 6, and we'll say like 8.7. And then last one, x when f of x equals 5, so we're looking at the vertical axis where it equals 5, and this is the only point where f of x is at 5, so this is right, if we estimate, kind of right at about 1.4 or so. Okay, so these are, again, x values, so x equals 1.4 right there. Okay. Your before class, you're going to be doing similar to what the example that I just did. So you're going to find the value of f of 4, f of 6. You're going to find x when f of x equals 2 or 1. And then you're going to answer this question, how many values make f of x equals 0.5 true? So how many different places does f of x equal 0.5?